Alright, now that we've gone through our hypotheses, when it comes time to make a decision about the hypothesis, um, whatever decision we make, we we could be correct, but there's always a possibility that we are wrong. Okay? Now, this is called type 1 and type 2 errors. When we initially do a hypothesis test, we assume that the null hypothesis is true. We go through and we're going to make a decision whether to reject the null hypothesis, meaning that our assumption was incorrect, or we're not going to reject the null hypothesis, meaning our assumption is probably correct. Okay? Now, the null hypothesis, we're assuming it to be true, but just because we assume something's true doesn't make it actually true. But either way, we're going to assume that it's true. Now, if it is actually true, or if it's actually false, that's going to tell us whether we have a type 1 or type 2 error. Now, let's look at this. If the null hypothesis is actually true, that means our assumption was correct. But then we do our hypothesis test, we get our numbers, and for whatever reason, we reject the null hypothesis. Okay? Well, why should we reject the null hypothesis if it's actually true? Remember, we don't know if it's actually true. We're just assuming it to be true. But if it is actually true and we reject it, we made a type 1 error. Now, we assume that it was false, we assume that it's true, going through our analysis, get our numbers, we reject it, and if the null hypothesis is actually false, we made the right decision. Because if it's actually false and we rejected it, okay, yeah, we want to reject something that's false. Okay, so then we made the correct decision. Now, down here, if the null hypothesis is actually true, and we don't reject the null hypothesis, we made the correct decision. It means our assumption, we're probably right. Okay, so we made the correct decision because it's actually true. Now, if it's actually false, we don't want to take something in that's actually false. If we don't reject it, we just made a type 2 error. Right? Now, that was just speaking out the definitions of type 1 and type 2 error. Let's go ahead. There's a very concrete example in our judicial system that explains this perfectly. Okay? Now, when you commit a crime and you have to go to court, you are assumed innocent until proven guilty. Okay? So, let's go ahead. Let's write it up here. Let's keep this here. I know you have it in your notes. So, we commit a crime, we go to court. Innocent. So, you're innocent until proven guilty. And this is the prosecution's claim. They claim you're guilty of some crime, okay? That's what happens when you go to court. Now, you're going to assume that you're innocent until proven guilty. Just because you're assuming you're innocent doesn't mean you're actually innocent. You could have actually did the crime, okay? Even if you did the crime, when you go into court, they still assume you're innocent until proven guilty, okay? So now, if you're actually innocent, okay, the null hypothesis is actually true. You did not actually commit this crime. And the court rejects your innocence, they reject the null hypothesis, but you were actually innocent because you actually did not do the crime. They just put an innocent man in jail or innocent woman in jail. Type 1 error. Okay? Now, if you're actually innocent, you did not commit this crime, and they don't reject the null hypothesis, they made the correct decision. Okay? You did not actually commit this crime. They're not rejecting the fact that you're innocent until proven guilty. They made the correct decision. Okay? Now, here's a better way to look at the do not reject as opposed to accepting. So you assume that you're innocent. If you're actually innocent, yeah, they made the correct decision. Do not reject. They just don't have enough evidence to say that you're not innocent. They don't accept your innocence, but they can't reject it either. They don't have enough evidence to show that you are guilty. Okay, it's not the same thing as accepting that you are innocent. Now, let's say H naught is actually false, right? Remember, you are assume that this is true. You assume that you are innocent until proven guilty. Now, say you actually did the crime, okay? And they reject the null hypothesis. They reject the assumption that you were innocent. Well, then you made the correct decision. You actually did the crime. They rejected your innocence. They're putting you in jail. Correct decision. Now, if you actually did the crime, and they don't reject your innocence, they don't reject the null hypothesis, but you actually did the crime, they just let a criminal go free, that is a type 2 error. Alright? So that is the difference. Something we gotta pay attention to, and it will pop up. I'll explain it when we go through a hypothesis test. When we get our final answer, what could it mean? Let's see. Sampling, distribution, and the type of test. Okay, we already talked about this. I'm not going to write it on the board. We can read through it. It says, the sampling distribution that will be used follows the same criteria for confidence intervals. Okay, you're going to use the Z distribution. The only time you use the Z distribution is for the population proportion, or for the mean when the population standard deviation is known. You're going to use the T distribution for a mean when you don't know the population proportion. You know the population standard deviation when you don't know the population standard deviation. Okay, and you know the sample standard deviation. Now, it says chi-squared. That's used for variance or standard deviation. We are not going to be doing hypothesis testing for the standard deviation variance, although you can. It's in Chapter 11, 11.3, I think. But we're not going to go through it. Now, the level of significance, okay? Before doing a hypothesis test, the researcher sets the level of significance, okay? What this is, it's the maximum, it's alpha level of and this is the maximum allowable error for a type 1 error. It's the maximum allowable probability. I forgot the word. Maximum allowable probability for a type 1 error. And I will mention this when we go over examples. Okay, so they can give you the confidence level in the problem. So confidence level, and if you want alpha, it's 1 minus the confidence level. But typically, they give you the alpha value from the get-go, okay? Right at the start of the problem, or not the start of the problem, at the end of the problem, they usually say test this with alpha equals whatever level of significance. Now, it depends what area you are doing this research in, what level of significance you would want to use. Now, in the social sciences, you want to use an alpha level of 0.1. Okay, psychology, sociology, something like that. Now, in the pharmaceutical industry, the level of significance is 0.01. Remember, the level of significance is the maximum allowable probability for a type 1 error. Now, remember, type 1 error, H naught is actually true, your null hypothesis is actually true, but you rejected it. You don't want to reject something that's actually true. So that's the level of significance is the probability of that happening, and they have their probability set as 0.01, 1%. Okay, but the most widely used is 5% or 0.05. Okay. Now there's one more thing. What type of test? What you're going to do is look at the alternative hypothesis. So if your alternative hypothesis says, now, this could be for whatever population parameter, it could be P, it could be mu, I'm just using mu here, is less than some number. K here is just any number, whatever number we're making our claim to be. So like in the fabric cleaner case, this was 0.9. Okay? This is a left tail test. When the alternative hypothesis looks like this is a right tail test. And when the alternative hypothesis looks like this is a two-tail test. This is important when we're calculating our p-value. Okay, that's the number we're going to use to make our decision. Now, how you could remember which is a left tail, right tail, or a two-tail test is look at the inequality signs. Okay, if you write this in a standard way, meaning you put the population parameter on the right, you put the number that is part of the claim, so like the 90% here, the 0.9, on the right, then when you look at your alternative hypothesis, look at the direction that the inequality sign is pointing. It is pointing to the left tail test. It is pointing to the right tail test. Not equal to two tail test. I mean, that one you just kind of got to remember. Okay, these can help you figure out what tail test you are doing. Okay. When you write up your hypothesis test, you are going to be asked, what kind of test is it? And you got to say, is it a left tail, right tail, or two tail test? Not only that, it's going to become important when we type this in on the calculator. You need to know which one to pick.